Last class we worked on how to create a scatter plot to show the relationship between two numerical variables, and we also calculated the sample correlation between those two variables, which we called R. In today's class, we're going to be talking about how to do a hypothesis test for a population correlation coefficient, which is called rho. It looks like the letter P, but it's a Greek letter. And the purpose of this test is to basically see that when we find a correlation between two variables in a sample, we want to see if that relationship is significant if we looked at a whole population of people. And we're going to do that using a hypothesis test. And as you very well know from other hypothesis tests that we've done in class so far, a hypothesis test can be one-tailed or two-tailed. In other words, the one-tailed test would be you're looking in one specific direction, either that you think that a correlation might be positive, so that would be the greater than test, or it might be you might think that a particular correlation that you're looking at is negative, which would be the less than test. It'd be less than 0. Or you might not know what type of correlation to expect. You might say it could be positive, it could be negative, you don't know, and that's a two-tailed test. Or in other words, it's the not equals test. Okay, so here's exactly what we just said right there. For your HO statements in each case, whether it be the left-tailed, the right-tailed, or the two-tailed test, both of them, those HOs basically say that there's no significant correlation going on. And your HA statement will always be that, yes, there is a significant correlation. So for the left-tailed test, this is basically saying, yes, we have a significant negative correlation. For the right-tailed test, if we reject the null hypothesis, this would say that the correlation is significantly positive. And for the two-tailed test, where it's not equals, rejecting the null hypothesis would basically say, yes, we have a significant correlation between variable x and variable y. So the test statistic that we use to actually do the correlation hypothesis test is the sample correlation. And we're going to plug it into the standardized test statistic formula, which is also a t-statistic that you've seen before. And essentially, this formula right here is the formula that, as you probably could guess, the graphing calculator will do for you. So as long as you know the sample correlation, it'll plug it in for R. It'll know the sample size, and it'll shoot out T for you very easily. As long as you can type in the data from last class to find the sample correlation, it'll shoot out the T statistic that you need. And it should be noted that the for a correlation test, the T distribution in terms of degrees of freedom is n minus 2. So if you have basically, for example, 6 pairs of data, so 6 x data points and 6 y data points, okay, n therefore would be 6. You have 6 pieces of data, so take away 2, the degrees of freedom would be 4. And you're going to use the same critical value calculator that you've used for the t-test for means. So just keep in mind that when you're trying to type in your degrees of freedom, it's always going to be n minus 2 for the correlation test. For this chapter, all of your hypothesis tests are going to be two-tailed. That'll be especially the case for the homework. So whenever you're doing a correlation test, it'll always be the equals not equals test, because basically the questions are just going to ask you, is there a significant correlation between variable x and variable y? Well, when you're saying is there a correlation, that basically means you don't really care if it's positive or negative. You're just trying to see, is there a correlation that's basically not 0, and that's the not equals test. Okay, so the steps for the t-test for a correlation We're going to state the null and alternative hypothesis, so write your HO and HA statements, which, as I just said earlier, will be very easy for this chapter because they're always going to be the equals not equals test. The alpha level will be given to you in your problem. Step 3, the degrees of freedom is n minus 2. Step 4, what are the critical values? You'll get those critical values from the UB-Learns critical value calculator. And because it's a two-tailed test, you're going to have a positive critical value and a negative critical value. The test statistics step 5 will come right out of the graphing calculator, and I will show you where that is. And then step 6, make a decision either to reject the null hypothesis, reject HO, or fail to reject. And that's the same rule of thumb we've used for other tests. So if your p-value that you get from your calculator is smaller than the alpha level, so for example, if alpha is 0.05, if your p-value is smaller than 0.05, then you can reject the null hypothesis. If your p-value, on the other hand, is bigger than your alpha level, then we cannot reject the null hypothesis. The hoe is sticking around. So let's take this data that we've done in class before, comparing GDP to carbon dioxide emissions, and let's test to see if there's a significant correlation. For basically, this is a sample of countries. Let's see if this relationship is significant for all countries. Can we generalize it to all nations? And we'll use an alpha level of 0.05. So first thing I would do is get the data into my calculator. So I'll turn it on, clear this out, go to Stat, click Enter. I'm going to clear out my calculator by highlighting L2 and hit Clear, Enter. Go over to column L1, hit Clear and Enter. You probably won't have to do this. I just had data stored in my calculator from an earlier problem I was working on. And in L1, I'm going to type in my GDP or X variable. And then arrow over to column L2, and that's where your Y variable is going to be entered, which is the carbon dioxide emissions. So 428.2. And then just go back really quick and just double check your data entry just to make sure there wasn't any mistakes here. So let me see, going down. Okay, X looks good. Yes. Okay, looks like everything got entered in just fine. So to actually run the hypothesis test, we're actually going to do just like we did at the end of class on Thursday, which was we're going to go to Stat, we're going to go over to Test, and we're going to go down to the very bottom where it says Linear Regression t-test, and we're going to hit Enter here. Okay, so it says where's your list of X data? It's in L1, so you don't have to change that. Where's your Y data? Is in L2. Don't have to change that. Frequency doesn't need to be changed. basically what type of test are you running, what type of correlation test. And you see there's that little P, which stands for rho, the population correlation. And we said it's a not equals test, so we don't have to change that. We go down and just hit calculate. Okay, so here where it says T equals 5.306, that is your standardized test statistic, or T value. And right underneath it, P equals is your P value. It says 7.227. And this E-4 is times 10 to the negative 4. Anytime you see scientific notation with P values, that means it's very, very, very small. It's basically almost close to 0, which is a very good sign. And then actually right underneath that, you see the degrees of freedom here. It actually counted up and knows that there's a sample size of 10, and it took away 2, so there's your 8 degrees of freedom. So this is really good because we have 8 degrees of freedom. We know the alpha level is 0.05. We could easily go into the critical value calculator on UB Learns and get those critical values really easily. But before I actually go and do that, let's just take a look at the p-value. Let's just kind of skip to like the last step. So if my p-value here is smaller than 0.05, then I can reject the null hypothesis that there's no correlation between GDP and carbon dioxide emissions. And we can see here, this is a really small number. It is smaller than 0.05, so I can reject the null hypothesis that there's no correlation. So in other words, yeah, I can prove, therefore, that in general, there is a relationship between GDP and carbon dioxide. And let me just skip to the next slide just so you can see exactly what they did. I mean, they worked it out by hand. Okay, there's our rejection region, which I'll show how we get that on UB Learns really quickly. There's the test statistic, which ours is a little bit more accurate because it doesn't have to deal with rounding error. And there's our little conclusion, which we just said too. So let's just finish up really quick. How do we get those critical values? So let me pause it for a second and I'll take you right to UB Learns. Alright, so here I am in UB Learns, and we're going to click the critical value calculator folder, which is inside course documents. We're going to click the t-test critical value calculator, and you can see it also says for correlations. Alright, we'll take that 8 degrees of freedom out of the calculator. And it was an alpha level 0.05 in the problem, so we'll hit calculate. Alright, and because it was an equals not equals test, we're going to look at the two-tailed critical values. So in other words, one of your critical values is positive 2.306 and the other one is negative 2.306. And essentially, those are the steps on how to do a hypothesis test in the graphing calculator. It's a very simple test, and it's basically it's using the same stuff we've already done in Thursday's class with finding the correlation. And in the next video, I'll show you really quickly how we can do a simple regression equation to basically predict values between an x variable and a y variable.